warahmatullahi wabarakatuh. Good morning. I would like to present my article that the title is Effect the effect Diffuser length and degree to horizontal wind turbine. Uh, the member of uh, my article is me as the leader of the study, Fatahul Arifin, Raden Kusmanto, Yohan Ribo, Rusdiana Sari, Ahmad Takwa, Apria Susandi, Yusuf Dewantoro Helambang, Minwen Wang, and Carlos. As we know that the problem of global energy is the rising cost of fossil energy, coal, gas, and oil. So that's why uh, in our article we introduce the way uh, to find the alternative energy, especially for wind turbine. As Parajev et al. Study about the various design experiments and CFD simulation of wind deflector on 7 years wind turbine type using CFD software, then conclude that installing a plate deflector in the 7 years turbine can increase the power coefficient by 27%. So in our study aim to analyze the performance of a horizontal axis wind turbine by applying various in the length and angle of the diffuser. And this is the our research methodology. We design the product, use the Autodesk Inventor, and then we analyze using ANSYS program uh, to analyze the CFD analysis, and then we make a product, then measure the diffuser, and we collect the data experiment, and we processing and analyze the data, and it's finished that the suitable with the literatures or references. This is our design. uh, the E figure one is the design of this puzzle, whereas the inlet and D and length, and also the degree of the diffuser. And then the B is a design of wind turbine with and without the diffuser. The design structure, the structure design of our turbine is like a figure two. This we analyze the the effect of diffuser, and according the result of running CFD, ANSYS applied in this research with a magnitude velocity is 5 meters per second. Then the diffuser angles were changed 4 degree, 8 degree, 12 degree, 16 degree, and the L equal 0.5 D to 2.5 D, while D equal 1200 millimeters. The result is so that the optimum diffuser angles are 8 degree to 16 degree, and the length is 0.25 D to 25D. As we can see in the figure 4, the wind enter the diffuser with the high velocity and then out the diffuser with a low velocity. The best profile velocity contour can be obtained at a higher diffuser angle, and then the diffuser length gives an excellent performance from 0.5D until 1.25D. And we can see in the figure 4 CFD of an ANSYS Fluent simulation for diffuser length 0.5D to 1.25D, and the angle is 4 degree to 16 degrees. If we compare to each other, the power generated in the theory and the experiment result, based on the theories and experiment, it is possible to compare the power generated in the turbine without and with a diffuser. And we can see in the figure 5 to 7, it can observe that by theory there is an increase in the power in the wind speed range 1 to 5.5 meter per second for each diffuser angle compared to the power of the horizontal axis wind turbine without a diffuser is 1.3 to 1.4 times. A diffuser with a length of L equal 0.5D and an angle of 8 degree can simulate an increase in the turbine power of about 1.3 times. Meanwhile, a diffuser with a length of L equal 0.5D and an angle of 12 degree can increase power up to 1.4 times. And we can see in the figure 5, power generated by HAWT without the diffuser theory and experiment. And the figure 6, the power generated by wind turbine with a diffuser 8 degree. The figure 7, power generated by wind turbine with a diffuser 12 degree. And we can see in the table that the average enhance of the turbine power in theory is 1.3 for diffuser axis wind turbine, uh, 8 degree is average is 26.687, and 12 degree is 28.302. And in experiment that the average is 1.602 2.163. So in our conclusion that the simulation results show that the length of the diffuser gives a better effect on the performance of the wind turbine. Namely, the length of this diffuser L is 0.25D to 1.25D, and the angle of this diffuser is 8 degrees to 16 degrees. The experiment work find that the three wind turbine condition. So the diffuser with diffuser length L 0.5D and the diffuser angle of 8. The experiment data graph show the wind speed dramatically affect the voltage and the electric current generated. If the wind speed is higher, voltage and the electric current generated will be higher too. The higher the effect of installing a diffuser with a certain length and angle can increase the power generated by the wind turbine. The ratio of enhancement of the power of the diffuser wind turbine to wind turbine without a diffuser is 1.6 to 2.1 times. I think that's all I can present about our article. Thank you for your attention.